Hello, folks. Good evening. Why the hell am I live? I don't know why I'm live. But I figured I would do some work because there's so much left to do. Let's get a quick word count here. It's pretty good, honestly. This being all the code. I've got some ice cream. I'm gonna sit here for a few minutes. We're gonna sort of think about some stuff, and then we're gonna do a couple of refactor ops. What do we have? We've got 2,700 lines. I think we'll just have this hit on. Let's just flip the screen over to this. I think maybe the policy. I think this is like a good thing to look at, right? Well. Hello, folks. Evening. I'm not sure if I'm a fan of the way that we're doing our policies here, you know? First of all, I don't know if I want to use C++ classes at all. And second of all, the way we're registering buffers seems really bloated, no? Hmm. I guess it's because it's split, right? Okay, this append param shape should not have to exist at all. So we'll see why that exists. I don't know why this has to exist, honestly. Hello, Yongxian, welcome. I guess I see some of the issue though, right? So you essentially, it's because you're registering the shape. You register the shape, right? Hmm. And then after you register the shape, right, you then have to init the network. Hmm. I think I have orthogonal on everything right now. Remember back when stuff didn't work because we had bad initializations and bad activations? That was janky. That's more than a decade ago now. I kind of see why I have it this way, though. This register activations. Let's look at the forward pass. Well, this is pretty clean. Some of this is a bit messy, right? A little messy. Well, it's because, like, there's no mini-brew layer. It's just all batched. So that's not great. So this isn't even super long. It's just that it's all together. And then I don't know what this is for. Everything else here kind of makes sense. I don't know why we have two separate register functions as well. I should just go on a knit if we're going to do it that way. Just the grouping of stuff kind of sucks. So, like, let's say that we think that there's a fair bit of code saved here, okay? Like, because admittedly, this is a really shitty way to write networks. And just looking at this code does not bring joy, right? It's pretty impressive it's this short. But this does not bring joy. At all. I don't know why we need this. I mean, really quite a bit of the code's kind of bad right now, no? At least that's all there is of it. It's really not that long anymore, huh? We got some kernels up here. At least some of this will get deleted. It's like on one hand, this is actually really, really good use case for just C++ constructor, all the registration stuff. And on the other hand, I don't really like to have a bunch of C++ classes. Also, do they even need their own functions? Their own register functions? I suppose they do. I'm positive. Okay. Ice cream is done. Dietary requirements. Extra calories needed. And if you're super sore from leg day the previous day, have some ice cream for dessert. It'll work wonders. Well, this is the worst of both worlds here, right? Train graph. This is like the dumbest possible to use, right? That we have separated. I don't know how we get to this point, right? This is the dumbest possible use. That we're creating this crap and then separately somehow registering it. Oh, because it's just a struct, huh? Oh, that's so weird, man. That is so weird. Now, you definitely don't need a constructor. Let's just go through and do the CC tag thing that I do, where we kind of just like add a bunch of tags on, like add a bunch of comment tags. Hey Pico, what kernel is this? This is not a kernel. This is the whole training file. So take a look. This is the source directory. So this is everything in Puffer, everything in the new train backend. You can ignore this file. This is our like web thingy. It's just these 5 files. Total is, if you take this out, just under 4,500 lines. And it's all CUDA, so that you can call launch functions from anywhere and you don't have to expose additional, like you don't need additional headers to expose stuff. So the whole thing is just compiled in VCC. It's very nice. And right now we have 1,000 lines worth of models crap, which doesn't have any inline kernels, but calls launch functions from here. And we have 1,600-ish lines of native kernels. And I think there's quite a bit of bloat here, and there's a little bit of bloat here. So what I'd like to do is I'd like to get more stuff into kernels, compacted a little. This will end up about the same size. I want to cut a few hundred lines out of this as bloat. And I'd like to end this somewhere south of 4,000 lines. But we're not going to do that by one-lining if statements like a bunch of goons. Like a mega kernel. No, this is not one kernel. So the idea, right, you don't have to just write kernels in .cu files. If you write in .cu, you have access, you can write C, you can write C++, and you can write CUDA. So if you split your stuff up so that your kernels are in .cu files, and and the launch functions also have to be there. Well, actually, look, if you write your stuff in a .cu file and then you call it from a .c++, first of all, you need to write a launch function in the .cu because the launch syntax requires CUDA. So first you have to write one wrapper function for every kernel. And then you have to write a header function for every kernel because you can't include the kernel code directly in the C++. So you essentially have to add 2 additional things for every single kernel, right? Whereas if I just write everything in .cu, I don't need launch functions because I can just call launches directly. I don't need a launch function, and I don't need the extra header. So I save 2 spaces. I save 2-fold redundancy right there. And there's really no downside to this at all. That's cool? Yeah, I think so. I definitely think so. So much crap code in here, though, man. We'll have to do it in passes. We'll leave the allocators alone for now, though. Prio buffers. Okay, we'll leave these ones alone for now. Leave this one alone. It's kind of weird. Okay, we'll leave this alone for now. Yeah, it's super stupid with how this is. Spencer reporting self-play. We've been working on a client project, man. But it's obviously going to have to get done. The thing is, the code still is a mess, Jess. I'm trying my best to get it to be not a mess tonight. As you can see, I am here at 8 p.m. putting in extra work. So, I'm doing what I can. We're going to see if I get bitten in the ass for this, but we'll try this. Sorry if I'm coming off. No, man, you are good. Don't you worry. I want to hear more chess updates for sure. I've just been fighting the demons for a few days here. Look, we got this, subtract this, so we've got 4,500 lines of code, and I need to get it down to 4,000 lines of code or less, I think. That would probably be pretty slim. Well, that's kind of a proxy. Realistically, I just have to make the code not suck. Mm-hmm. How many of these are dumb at the bottom here? At least some of these are dumb, right? I really want to just drop the orthogonal in it and risk it, but I know I shouldn't. I think this is going to make this file a little longer, unfortunately, before it gets shorter. If we end negative lines, though, for tonight, I'll be happy. I mean, even something like this, like, I have to think about this to see if this is completely dumb or not, right? Like, what is this? Yeah, the plan for tonight, it's 8. I'm going to do a couple hours of this. I want to get the models CU into like more C-style simple code. I don't think we're going to completely eliminate the C++ today, but I think I want to get it closer. I like the more I see like, oh, this C++ thing, that C++ thing, they always look useful, but then I'm never sad that I removed them. It's just a bad language. Yeah. The thing that like alec.reg, it's a little awkward the fact that you have to do all the registrations first, I suppose. It's kind of a nice way to enforce static, though. Hmm. Is there actually a way to do is there actually a way to do it this way? So let me look that up. I actually don't know. I'm like wondering if there's actually a way to restrict. Hmm. No, this is not good. I think not terrible. It's good to see. You just write C and you just don't use the C++. so much C++ jank in here. Let's see what the code looks like after I do this, at least. Let's see what it looks like. Quite dumb refactor. All right, what do we have here? Whole bunch of errors in here. Okay, we'll just do that for now. It's very stupid. Include suck. It didn't get longer at the very least, right? Dude, how stupid is this thing? Holy crap. It didn't put them in, Okay, well this thing did it completely fucking wrong. Should I just do this myself? Probably be more fun. Why don't we? Why don't I just throw some music on and like start manually refactoring some stuff? Probably be nice to see the amount of damage that we've done to the code base. Probably the best way to figure it out. Alright, we're gonna do some real refactors. Fuck off, Claude, you're stupid. At least if it builds. I want at least to start with a working build. Okay. Double dipping today? I'm doing 2 streams, my guy. Try to rebuild without force. There. Way better, right? Some C++ brain damage. What the fuck is this brain damage? Holy. I honestly can't even do this by hand. The code is still too bad. That's disgusting. That's like disgusting. I literally can't edit the code by hand. It's that bad. Well, we're nowhere near done. Yeah, this will be much better. That's crazy though. I start editing the code manually and 30 seconds in, I just hit like, what the hell, C++. I know it's not even that complicated, right? I know it's just like a constructor called in the default initializer thing, but it's gross, and I don't want to deal with that shit. Like, language got too much syntax. Doesn't even help you. What part of the code? I'll show you. All right, look at this. Like, okay, you got this default constructor that does nothing, and then you got this thing that, like, in the initializer list, calls the constructor of the encoder, so it's implicit on the encoder, the constructor, and then this one, and then this one. So it calls 3 constructors and then the setters. Like, what the fuck? No. You'll see when I'm done with it. Like, it's literally simpler code and it's the same length in C. Why the fuck would you ever do this? Because, like, I can't edit one piece of this. Like, I'd have to move this, I guess, into this. Like, I guess you could do it, but I don't even want this function to exist, right? It's just C++ brain rot. It's like you look at any one piece of the language and it's like, oh, okay, I could see that being a reasonable language feature. But then every single stupid thing they bolted onto C, you can just do it in C and it's easier. That looks like normal C++ to me, exactly, but normal C++ is ass. You're going to see, I'm going to rewrite this stuff. It's going to end up mostly C style. It's going to be the same amount of code or shorter, and it's going to be less crap. It's just a bad language, man. The C++ is inherited from Torch, right? Because like we refactored it to be C++ without Torch. But then what if we just have nice Q to C? Like technically it has to be C++ compatible or whatever because it's, you know, NVCC compiles C++. But you can just write C. The heck did it just do? Okay, this is what we wanted. Lose market share? No. Not at all, Jay Sully. So we have, first of all, this is all Torch compatible. You can literally just call from blob on our tensors and run whatever Torch ops you want. We're going to have a Python fallback. Like if you want to just run stuff in the Python and have it be faster than every other library other than Puffer, but 5 times slower than Puffer native, you can. But if you want to run training 15 to 20 million steps per second, you can use our native code. And guess what? It's literally shorter than the Torch. So before I got rid of the Torch, right, the Torch C++, which was a gross, awful Torch C++, with a million things you had to learn in order to understand what was going on, I had 3,500 lines. Now I have 4,500 lines without Torch, and it's going to end up being under 4,000 by the time I'm done with it. So what the hell is the point of Torch? Tell me that. It's also literally faster. It's fully deterministic, fully reproducible experiments now. It's all static memory, no dynamic memory allocations, no running out of memory mid-training run anymore. I'm telling you, AutoGrad is a scam. Okay, this is literally the same amount of code as we had before as well, for having changed that. It's not good yet, though, don't worry. This is not what I consider good. This is considered getting there. It's just so crap, man. Fucking code is so bad. It's just a million little incremental refactor ops and they'll be good. That's all it is. Muon's gotta get the same treatment. So good, right? See, this is crap, but if we end up deleting most of these, it's no longer crap. This is fine. Yeah, I know how to refactor this now. I'm still going to use the stupid language model for it because it's just so much code to change. But even the compact here is like, it's just burning tokens. I think I'll just do a new session of this. That's crazy. And what am I supposed to do though? It's kind of funny, you know, I'm probably going to know that I'm done with this. I'm done refactoring when I notice that I've been refactoring by hand for a few days and I haven't wanted to use the language model. That'll be how I know it's good. Because when I'm writing sim code, I don't feel like using the stupid language model constantly. I kind of just write my sim code. It's only when stuff is a complete mess that it's like, well, what the hell am I supposed to do? Okay, code's the exact same length it was before. No more C++. Right here, create policy, right? There we go, much better. No, you fuck. This thing is so shit. Tries to stick them all under the fucking encoder. Like, goddamn. So stupid. There we go. This is it, right? That wasn't hard, now was it? Okay, this one's different. So this one's a little complicated, that's fine, but this is at least better. Now it does this, great. We end up with 3. So we only merged 2. Okay, well, it's better than nothing. Oops. Well, what the hell are we doing? Wait, what the fuck? Why is it like this? Well, if this is the design, then it's shit. It's a shit. Great. So then this design is shit, is what's the problem. If you can't merge these. Why can't these two get merged? I mean, this one I understand. Let's see. That's quite shit. So we're gonna have to redesign some stuff. Hmm. Okay, this is actually genuinely kind of complicated. Hang on, let me figure this out. So why register activations and register inference? Why are these different? Register activations, register inference. Okay, this one I understand. Oh, is this for training? This is for training. Yeah, but this is still stupid, right? So this is the encoder in it. I guess the only one I don't understand is these. I don't understand why we can't merge this. Doesn't need. Okay, I see. We don't need these. Okay. So this is why autograd exists. That's not the right solution, but I see the problem that they hit. Cool. Well, actually, I don't see the problem they hit because this is way more sophisticated than anything Torch has, to be fair. This is all static memory. Multi-buffered rollouts. Options, options, options. Hmm, hmm, hmm. Well, I mean, this is actually something like this is pretty sophisticated. Cool. That's real stuff we're building. Um, I still have to figure out a way to do this that doesn't suck though. So the idea is some stuff you gotta save during inference. Can't have four freaking functions. I suppose I can try to explain the problem I'm facing here. So, when you init the encoder, you have to specify how much space you need for the params and grabs. All the allocations happen at once, so you just tell it how much space you need, and then the init happens later. That's why there's a separate init waits. Okay, but then that's kind of okay. But now the thing is, there's also these two different register activations functions. There's a register activations that is used for training, that creates all the buffers that you need for the network for training. And then there's one for inference. But because we do inference on a bunch of workers in parallel, you end up creating several of those. How the hell do I do this without just writing a C++ class? Well, see, now the annoying thing is because I've seen it in a C++ class, I have the mental bias. If I hadn't seen that, how would I do it? It's grouped completely wrong. Let's see what that looks like. What made you think about trying layer norm in neural MMO 3? Um, Drive project with NYU. It was like a small enhancement. We're gonna try. Actually, I think we can do with it. We can probably do without it now. I don't know. There's some stuff we gotta do though, Jess. That's weird. Man, kind of tough design problem, isn't it? This is gonna make it really shitty to have multiple networks, isn't it? If I don't have a base class. Fuck. I might have to accept a very small amount of C++ to do this. I see how I can combine all the functions. Shit, I don't actually think I don't even think that saves this here. Hang on, does it? Yes, wait, it does. We can do something super minimal. Let's assume I can do it, because I think I can. No, but you don't want that, do you? Init. Jess. The thing is, you actually want all these functions is the annoying thing. I'm looking at it. I mean, what can I say? It's a pretty damn complicated app, right? We've got parallel rollouts. There's no way around this if you want parallel rollouts with static memory. It's at least not needless complexity. We'll be able to bind them under one clean interface though. We'll make it not shit. We can easily do the same thing with the decoder. It's just going to be a couple of namespaces, right? But we can still mostly have the same thing. Yeah, I think we can just clean apply this to everything. Okay, this is fun. Okay, so it's doing stupid things, but we can correct this. Blah, 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 blah. there's so much to be done here. Okay, what we're gonna do, we'll separate it first, and then there's gonna have to be an interface. Because, like, I'm realizing... Well, we can... I don't know if you can do that with type defs. I could do void star encoder, but I don't like that. It seems shitty to me. I'm thinking what we're doing with these interface like this here. Yeah. This is probably the main section where, like, if this is bad, then Puffer is bad, is the problem with this. We can forgive bloat elsewhere, we cannot forgive bloat here. 22 mil? That's eval SPS at the end of training, dude. That's also on my low-end machine, though. Also tiny network, but it solves. Yeah, convert. This is torch free. There's no torch. Okay. Should not have constructor. This is better. This looks worse, but this is going to be better. Trust me. Because it looks like a bunch of code. It's going to be less code. And actually, we've only added all this so far. We've only added 30 lines. So we haven't actually made that much of a mess. It's some work. Okay, good. I hate these freaking initializers. Good. That's way better. We still got vectors and crap. But this is good. It's better. This is still a whole mess of code. We've got a lot of the jank out of it, but there's a whole mess of code. Okay. Now decoder. I believe these two have. Let's see, Mingru. Mingru does not have encoder policy. Yeah, here. This is part of why the policy is so jank. Policy should be very small. There we go. Still a mess. Getting somewhere. These lines, you can just tell looking at it. Look, these lines are way too long. So we're either going to gain a ton of lines or unstupid the code. One of the two, or both. Oh, that's actually going to simplify the policy backward a lot, isn't it? Because this is all for the decoder. Yeah, that's actually worth it. Yeah, that's better. Look at this. So policy forward, train, policy backward. This is what we want. This runs. This is good progress. Hey, what's up? We are refactoring garbage. And by garbage, I mean the fastest RL library out there, but the code is garbage. I gotta fix it. It's kind of crap. It's not that far off from being good, but it's gonna take some work. Okay, so batch sizes for PPO, 512 steps, longer rollout length. Would you still keep credit assignment? Wait, hang on. Let me answer this. Let me pause the music. I have some answer this correctly. So, needing credit assignment over 512 steps in the general case is just impossible. Like, if you have a 512 exponentially deep search problem, you just can't learn that with any algorithm. You're screwed. Now, a lot of problems, right, they have a lot shorter credit horizons that you can just easily chain together. So you don't actually need really long segments because it's really hard to learn credit assignment over super long horizons anyways, and you do get a bootstrap out of the backprop anyways. For 512 steps, so the problem with if you keep num_ems high, I think it's going to be more efficient in Puffer 4, but you're going to make your training code really slow, right? Because, so with Puffer 3, you have the LSTM policy. So you're doing sequential, like the LSTM is sequential over time steps. That's really, really freaking slow. So it's kind of never worth making your training super slow because if it doesn't run fast enough to train, it doesn't run fast enough to train. In Puffer 4, I think you're going to be able to take a trade-off somewhere more in the middle because we have parallel scan min group. So you get recurrence, but it's not actually linear in time. It's better than that. You get to parallelize all the map moles. So you can actually consider bumping up the horizon and you won't need any intuition because it'll just be part of the hyperparameter sweep, which is the nice thing. So if that's a worthwhile trade-off, it'll just make the trade-off for you. Whereas in Puffer 3, it's not going to make that trade-off for you because it's hardware inefficient. So that's a very engineering-sided answer, but that's honestly how you should be thinking about these things, because most of these decisions are just purely speed, and they have really, really, really big impact on speed. Like, just the architecture change in Puffer 4 allows us to actually consider your question, right? Because like in Puffer 3, the answer would just be, no, that's too slow to be usable. True for pretty much every other library as well. Transformers, you out of luck. Mm-hmm. Did I see multiple buffers in here? I thought I saw multiple buffers. Does PufferLib? Hang on. Does PufferLib? Yada yada yada. Pause this. Standalone import. So maybe is it? No, it's standalone, man. You can go grab it. It's just in PufferLib sweep.py. It's not really dependent on any of our other stuff. And protein is going to stay in Python for Puffer 4. So that'll just stay as is. Our training backend in Puffer 4 is going to be, well, you'll still be able to use pieces of it, but you're not going to be able to use like pieces of it just by copy and pasting a Python file, because it's stupidly high performance C and CUDA. But it'll still be pretty solid. We're going to leave Python training in as an option. I think or at the very least, you'll be able to just import like our core net and use that. I don't know, it's so difficult. What do you do when the entire field has just converged on a set of really abstracted tools that are fundamentally the wrong way to build stuff if you want things to run at a reasonable speed? Like, we had to throw away Torch. Like, you can still use it with Torch, but like, don't kid yourself into thinking Torch is doing any of the work. We're doing all the work. All of it. Ugh. Wait, decode train buffer, buff, and grad target. Huh? Mixed precision, lovely. Okay, well, we'll have to figure out how to simplify. We added some code, sadly. Added like 100 lines. I'm a little confused by this, honestly. Does this actually do anything? Accumulate into. I'm a little confused. I don't think this does anything. Right? I think we're being stupid. That's what's going on here. If this is the case, then we can make it simple enough. Side monitor training progress. 94. Work's been so ridiculous. Last few days I just had to keep dish on decide. That was a good find. So that means that we'll be able to do yeah, that'll make it a fair bit simpler. That'll make it a fair bit simpler. I think that was gonna be that alone will help a lot. Let's see what it looks like afterwards. Yeah, that's some bullshit genetics you got there, my guy. Jesus. Okay. Lifted for 3 years. My resting heart rate was 83. Lean. Ran for 3 years. Got it down to like 70. Hopefully I'm right about this, otherwise it'll break shit. We'll see. This is the last thing I'm going to do for the night as well. This 2-hour stream. A little longer. Not a bad extra evening session. Spot. We probably can just put some stuff in, like these grads and stuff can go into a buffer. Let's see. Yeah, that's substantially easier, isn't it? There's still some, like, a bunch of stuff, but what in the fuck, dude? What the shit is this? I didn't have that before. Cast? The fuck is this? Okay, well, I do have to fix this as well, because this is what language models do, by the way. Totally superhuman programming. Look at this. All, like, anonymous function gather, fucking calls it for some reason. I'm gonna end up having to revert this whole thing, right? This thing is so stupid. Finish first. Okay, we don't need the view. Why is it zeroing the grad? If this breaks training, we're just reverting it, and this thing is just dumb as fuck. I'm just gonna call it a night as well. Just does random shit for no reason. These two trains. Yeah, we'll do this. Swear thing just as. We will continue to fight the demons. I swear. It's like just the twisted logic, man. I think that the new latest opinion here is simply that most devs, as well as language models, are incapable of reasoning. Let's go look back in the meantime. We may as well. Like, what is something like this? Adding us a bunch of freaking kernels. Great. Trying me, guys. It's so much bullshit. At least here. Okay, this is just a kernel call. This is just like bad formatting. Okay, I think these two are just bad formatting for the most part. Maybe signatures. This is pretty simple. We got too many of these little functions. I don't understand how it always adds more code every time. They should have removed a lot of code. At least this is gone. Good. I feel like frickin' Michelangelo here. You know, there's a statue in this shitty rock somewhere. Jesus. The good news is more stuff is fused. The bad news is I'm sure it's done in a very stupid way. And possibly even broken. Actually, I'd say there's a good 50-50 this is broken. I will say it's surprisingly good at not breaking stuff. It's really shit at doing stuff in a way that remotely makes any sense. It's surprisingly good at not breaking stuff, but it does that too sometimes. Zero score. Let's at least see what it did with Muon. Well, this whole register buffers thing is fucking dumb. You don't need this. This one is good here at the bottom. I gotta merge more of these fish in. These are so funny. I like this tank. It's gonna try to look for commits and I'm gonna lose my fucking mind, right? It unvectorized my fucking update, didn't it? No wonder we're losing perf. Like the world's dumbest AI. Lovely. Well, it's gonna be some more work, guys. This will be for tomorrow, though. As soon as I have a version of this build that works, I'm gonna call it for the day. Look at this. Look how dumb this is. Like, literally. I don't know why it would try to do the weight update there. We'll get our perf back. It's funny, like we don't even see the perf diff as badly here because of how much lower overhead everything is, but still. What is this thing doing? hope we don't just have to revert this stuff. Suck. It didn't have to fucking do this, is the thing. Should I just revert it? I'll let it finish this, and if not, I'll revert it. It just randomly decided to fuck all the optimizer code. I should have noticed while it was doing it. This is what happens when it's too late. I get tired. Nothing, Jess. I did one refactor op and it fucked with something else for no goddamn reason. Aside from the fact that this is doing this inside the for loop for absolutely no reason, this will be better. They have to revert. We'll just restore to here and call it for tonight. I'm too tired to deal with this shit. See, and here it's actually, it's outside the kernel here. So it just decided to fuck this for no reason. Alright. Yeah, I'm just gonna call it for tonight. I'm too tired to deal with this. I have some client work to do tomorrow. I also have a presentation to prep. I'm gonna see if I can also get some stream hours in on this. We shall see. but I gotta call it for the night. I'm exhausted. Thank you all for tuning in. Start the Puffer on GitHub if you want to help me out. This stuff is a mess. I'm not gonna release it until it's clean. Like, this code here can literally be as easy or easier to follow than the equivalent torch. And I'm gonna get it to be there and faster.